Hi, my name is Mihai Heder and I want to introduce our project in which we are creating a web frontend to create rich documents which are also enhanced with machine representation. This is sometimes called semantic annotation, semantic data, formalized data, and so on. In this system, you are not interacting with the representation itself. Instead, you are confronted with suggestions and recommendations in natural language, and as you accept the recommendations or suggestions, the annotations are inserted into the content. Okay, our most complete application right now is a Wikipedia editor called Sztakipedia. It is found in pedia.staki.hu, and I'm going to make a demo with this right now. What you have on Wikipedia is sometimes book reviews. This is what I have prepared here, the text itself. Okay, the front end is a regular TinyMC editor. You can use the usual functions like the bullet list creation, tables, and so on. And at some point, you're gonna press the Analyze button. What is happening now is that my content is sent to the server, and from there it is distributed to many services, access to a REST interface. Many of them are based on UMA modules, annotation engines. Others are based on external APIs like the Yahoo API. Now the first thing which is happening is that the content gets some natural language processing. The results are not shown directly here, so I'm going to show that in the status console. What we have here is tokenization, sentence boundaries and tokens, also the stemming of the tokens, and also we have the TF-IDF measures which are calculated on the whole Wikipedia, which are downloaded and used as a corpus to make this calculation. We also have multi-word expressions recognized from the text. This is based on the work done by the University of Leipzig in the great WordShots project. We are using the same tools. We annotated the English Wikipedia, we processed it with this tool, and now we have the two-word expressions based on co-occurrence and significance. Okay, we also use, for the same purposes, the Yahoo Terms API, in which you send your text and it returns you with the most important expressions from the text. Okay, once you have this data, this information, you can have some interesting recommendations. The first I want to talk about is page links. Page links are links to important wiki pages in the text, like knowledge, computer, epistemology here. You can also read the first few sentences of the given articles. Now these link recommendations are based on the TF-IDF measures multiplied with the statistics get from the DBpedia about the linking of particular articles. So after we have this multiplication, we have a weight measure, and we get the most important, the highest weight measures from the text, and there we can establish the most important links. And then we make the recommendations. The user can accept these recommendations for the epistemology, computer, and there you have the links in the text. Okay, we have recommendations to external sites from the Yahoo Build Your Own Search Service API. For instance, for the word ontological status, this is the first 4 hits, and the second one is quite okay, so I'm going to accept this. And then you have the external link in the text. Also, we use the Yahoo Search API to find categories of this text. What we are doing is a really simple hack. actually, we are searching for Wikipedia category, and then there goes the important expression like Wikipedia category computer knowledge, and we get the first three results, but we use the en.wikipedia.org as scoped, so this is a scoped search. And what we have here is knowledge representation, for instance, which is quite okay for this article. And then you have the category link at the end of the content. Okay, what we have here is infobox predictions. This is based on machine learning. We tried many approaches like support vector machines, neural nets, and so on. But we ended up using Lucene more documents like this function. We indexed the whole English Wikipedia, and then you have this text here. It is searched in this index database, and similar documents to this text are found, and the info boxes from that documents are recommended as info boxes to this document as well. Okay, and once you accept this recommendation, you can see the template empty here, and as you click on it, you can fill the individual fields. Okay, I'm not going to fill all of them. You have some help text to the individual fields, you have the optional fields. This is all extracted from Wikipedia itself, actually from the page of the book info box in this case. Okay, once it's saved, you see the title of this book there. And finally, we have citation recommendations. Thanks to the British Library, who made the whole British Library database accessible in RDF format under terms of Creative Commons. And from that, we built a large database with Lucene plus Solr. And what we are simply doing is just searching for these important expressions like ontological status in the bibliography database. It contains the subject of the books and a short description of the books and so on, and we use what comes up as a result. For instance, understanding a word and integral ontology, maybe it's handy for this article. And there you have the sidebook template inserted. You can edit this with the same editor, and once you're finished, you can press the save button, and you get your wiki text back. Of course, you can edit existing wiki articles as well, like links here, my favorite. We have a new wiki parser based on Java CC, and it parses the wiki text, converts it to HTML suitable for this TinyMCA instance, and there you have the templates and info boxes like the taxa box. You can edit this, and you can save the articles. The articles are not saved to the Wikipedia directly back because we already messed up with some important articles. So instead, you just get the result in this text area here. Okay, that was Sztakipedia. Thank you for watching. If you are still interested, please join our Google group. We are going to make the announcements about this tool in the future at this group. Thank you very much. Bye.